So here we have the other inverse of the hyperbolic as a logarithmic identities. So we have here the inverse of hyperbolic sine, the inverse of hyperbolic tan, and etc. All of them are in the form of the logarithmic function. So for example, if you know what is the inverse of hyperbolic sine, you can know what is the inverse of hyperbolic cosine. Just you need to see the difference. Here we have square root of x squared plus 1, here we have square root of x squared minus 1. Similarly, if you compare the inverse of hyperbolic tan with the inverse of hyperbolic cotangent, here we have 1 plus x divided by 1 minus x. Here we have x plus 1 divided by x minus 1. And similarly for the inverse of hyperbolic sec and the inverse of hyperbolic cosecant. So also we need to know what is the derivative of the inverse of hyperbolic function. So let us do what is the derivative of the inverse of hyperbolic sine. So y is equal the inverse of hyperbolic sine. Now we need to find what is the derivative of this inverse. So if y is equal inverse of hyperbolic sine, that means x is equal hyperbolic sine of y. So now we will differentiate this equation, both of the side by x. Differentiate both of sides with respect to x. So we add here d over dx, d over dx. Derivative of x will be 1. Derivative of hyperbolic sine will be hyperbolic cosine. And we need to multiply it by dy over dx since our function is function of y and we differentiate with respect to x. So if we put dy over dx in one side, we get dy over dx is 1 over hyperbolic cosine of y. And we use the trigonometric identities that hyperbolic cosine square minus hyperbolic sine square is equal 1. So now the hyperbolic cosine square will be square root. Now the hyperbolic cosine y will be square root of hyperbolic sine square y plus 1. And you know that the hyperbolic sine y is just x. So here we get 1 over root of x square plus 1. So from the beginning, we have y is equal the inverse of hyperbolic sine. That means x is equal hyperbolic sine. We differentiate both sides with respect to x. Derivative of x will be 1. Derivative of hyperbolic sine will be hyperbolic cosine, and we multiply it by dy over dx. We will put dy over dx in one side, so we'll divide by hyperbolic cosine. We get dy over dx is equal 1 over hyperbolic cosine of y. We use the identity of the hyperbolic function, which is hyperbolic cosine square minus hyperbolic sine square is equal 1. So we need to rewrite the hyperbolic cosine of y, which is equal square root of hyperbolic sine square y plus 1. Now we replace this hyperbolic sine y by x, so we get 1 over root of x square plus 1. And here we have the derivative of inverse hyperbolic function. If u is equal g of x is a differentiable function, then we have all the derivative of the inverse of hyperbolic function. Similarly, you can make connection between the inverse of hyperbolic sine with the inverse of hyperbolic cosine. Just here you can see it is 1 over root u square plus 1, here 1 over root square u square minus 1. So here you have u square plus 1, here you have u square minus 1. Similarly, for the inverse of hyperbolic tan, we have 1 over 1 minus u square. Here you have 1 over 1 minus u 1 over 1 minus u square. And for the inverse of hyperbolic sec, also you can make a relation between this one and this one. So now let us do some example. So y is equal the inverse of hyperbolic cosine x squared plus 5. Given that the derivative of hyperbolic cosine of the inverse of hyperbolic cosine of u is given by 1 over root of u square minus 1. So here our u of x is x squared plus 5. The derivative of the inverse of hyperbolic cosine is equal 1 over square root of u square, so x squared plus 5 all square, minus 1 multiplied by du over dx, the derivative of x squared plus 5, which is 2x. So we have 2x divided by square root of, if you simplify this one, you will get x power 4 plus 10x squared plus 24. So just you need to apply this rule in the inverse of hyperbolic cosine to find the derivative. Then we have b, y is equal x multiplied by the inverse of hyperbolic tan x plus ln root of 1 minus x squared. where the derivative of the inverse of hyperbolic tan u is equal 1 over 1 minus u squared du over dx. So now first let us differentiate this part. Here we need to use the product rule since we have two functions. The first one is x, the second one is the inverse of hyperbolic tan. So let us differentiate the inverse of hyperbolic tan x will be 1 over 1 minus x squared. So we have 1 over 1 minus x squared multiplied by x plus derivative of x will be 1 multiplied by the inverse of hyperbolic tan x plus derivative of ln 1 minus x squared power half, it will be 1 over this part, so 1 over root of 1 minus x squared multiplied by the derivative of 1 minus x squared all power half, so it will be 1 over 2 multiplied by 1 minus x squared power minus half. Then we need to differentiate 1 minus x squared, which is minus 2x. So we differentiate this one is 3 times. First we differentiate with respect to ln. We differentiate with respect to ln. It will be 1 over what is inside ln, which is 1 over root 1 minus x squared. Then we differentiate with respect to the power, which is 1 minus x squared power half. So it will be half 1 minus x squared power minus half. Then we differentiate with 1 minus x squared. So the derivative will be minus 2x. If you simplify this, here you have x divided by 1 minus x squared plus the inverse of hyperbolic tan minus, here this half will cancel with this half, here you have minus x over 1 minus x squared. So this term is negative, this one is positive, you can cancel these two, so the derivative will be the inverse of hyperbolic tan of x. See, we have y is equal exponential of x squared, the inverse of hyperbolic sec. So given that the derivative of the inverse of hyperbolic sec is minus 1 over u square root of 1 minus u squared du over dx. So now if we want to differentiate this one, we need to use the product rule. First, let us find the derivative of the inverse of hyperbolic sec. It will be minus 1 over x root of 1 minus x squared, which is this one, multiplied by exponential of x squared plus the derivative of exponential of x squared will be exponential of x squared multiplied by the derivative of x squared, which is 2x. Then we multiply by the inverse of hyperbolic sec of x. And this is just a simplification of your evaluation.